An additional item I'd like to point out on the Ecoboost system, remember this is a forced induction engine. We need vacuum to assist our power brake system. So you may see on some Ecoboost engines, for example, this is a cutaway of the Mustang 2.3 liter Ecoboost engine. It's a cutaway of a camshaft driven mechanical vacuum pump so that we can rest assured that we always have enough vacuum for the brake booster. Now Ford will either utilize this mechanical pump for additional vacuum for the brake booster, or it may use an electric pump that may be found behind the left front headlight, such in the cases of Ford F-150. So either one of these may be utilized to provide additional vacuum for brake booster operation. Also on an Ecoboost engine, we have to realize that if we have a positive pressure in the intake manifold and the computer's commanding a purge of the EVAP system, there could be some danger as far as pressurizing the fuel tank, especially when we know that we may end up with a fuel mixture that's close to perfection or stoichiometric. That could be really dangerous. So Ford on the Ecoboost engine is using a special dual path purge for the turbo system. As you can see, if we happen to be purging during normal engine operation and we're not in a boost situation, we're going to flow from the charcoal canister, the fuel tank vapors, through the canister purge valve and move right into the intake manifold under vacuum. Now, if we're in a boost situation, the ejector valve, you can see, is tied to positive pressure and the suction side of the turbo. So we're going to route the fuel tank vapors in front of the turbo inlet and let it go that way instead of possibly pressurizing the fuel tank to protect any pressure in the tank. So this is a unique EVAP system that is utilized on the Ecoboost system because we're pressurizing the intake so we can still purge the EVAP vapors even in a boost situation. The slide that you're seeing here says no baro to hidden baro, and let me explain this. For many years, technicians might be looking at their scan tool and they will see a barometric pressure PID that's in hertz or frequency. Now, if they looked up the specs, they would find out that the specification is 158 to 160 hertz at sea level. For every 1,000 feet of elevation, the frequency drops a couple hertz. So let's say your shop is in Florida near the Gulf of Mexico. You're probably going to see, depending on the weather conditions and the atmospheric pressure, somewhere between 158 and 160 hertz. But today you're looking at the scan tool and you see 143 hertz. It's way out of spec. Well, I must have a defective barometric pressure sensor. There's not one. It is a calculated or inferred value that is really triggered off of the mass airflow calculation. The tip here is that it can be helpful to you. It's a dead giveaway that you have an undercalibrated or contaminated mass airflow sensor. The exception to this rule would be if the EGR valve is called an EGR system module that has the EGR control solenoid, DPFE sensor, and EGR valve all in one unit, or the total electronic stepper motor EGR valve, you'd have a separate map sensor that is the baro. But if you have a normal EGR vacuum operated EGR valve with separate EGR control and DPFE sensor, then it's calculated or inferred the frequency. Now what about if you look at the frequency and it says it's 172? If I was helping a technician with a problem vehicle and he says, Ron, what's really weird is that my baro frequency is 172 hertz. My very next question to him would be, does this vehicle have an aftermarket turbo or supercharger on it? If his answer is yes, then the tuner that tuned for the turbocharger or supercharger does not have the mass air transfer function correct. Now, if it does not have an aftermarket turbo or supercharger, then we're going to know that the mass airflow sensor is over-reporting airflow and load, and really the only fix for that is to replace the mass airflow sensor. Now moving to newer Fords with the Ecoboost engine family. We actually have a baro, but it's kind of hidden. The baro sensor is internal to the Bosch PCM. So now if you see frequency that's off or doesn't match your current atmospheric pressure, then you're going to possibly have to replace that Bosch PCM because the baro frequency or the barometric pressure sensor is internal. What we have during key on engine off is a pressure sensor correlation check. Let's take for example that we have a Ford F-150 twin turbo that has two canister pressure sensors, plus it's got the turbo inlet pressure sensor mounted on the charge air cooler, and it has the manifold absolute pressure sensor, and it has a baro sensor in the computer. That's a total of 5 different pressure sensors. The tip is check all pressure sensors at the same time key on engine off. For the most part, I would say in my career, over 30 years, 90% of any failure of a pressure sensor, it will show up under key on engine off. So do your pressure sensor correlation check, key on engine off. So as you can see, key on engine off, you may have turbo inlet pressure, manifold pressure, wastegate canister pressure, and the baro sensor. Here is the baro transfer function, how voltage and pressure are correlated to the computer from the internal barometric pressure sensor, known as the transfer function. There's our 5 pressure sensor check. Now obviously if you're a naturally aspirated late model Ford engine, you may only have baro pressure and manifold pressure. But most of the naturally aspirated Ford engines have mass airflow sensors. So we're typically talking about forced induction Ecoboost, which could have up to 5 different pressure sensors. There's our wastegate pressure sensor, which we may have up to 2, the transfer function for it. Now some of the manifold pressure sensors found on the intake manifold come in different varieties. We may have a 2-bar manifold absolute pressure sensor. That means it can read atmospheric pressure up to approximately 15 psi, then positive pressure of another atmospheric pressure or 15 psi. This means it could read up to 15 psi of positive boost pressure. Well, wait a minute, I've seen the Mustang Ecoboost in the right conditions spike up to 22 to 23 pounds of boost. In that case, we would exceed the limit of the 2-bar pressure sensor. So Ford does have, in some applications, a 3-bar or 3 atmospheric pressure sensor that could read up to 30 psi of positive boost pressure. And in some applications, this pressure sensor is a combo sensor, kind of like the digital mass air intake air temp sensor on the 6.4 Power Stroke, only now it's a mass airflow sensor, intake air temperature sensor all in one unit. But it can read up to 30 psi, and there's a shot of the transfer function, how the voltage is converted into pressure for the computer. Here we have a technician that's using his Snap-on Virus and just showing that he's doing a simple correlation check between barometric pressure and manifold absolute pressure sensor. You want to look at your PID list and pick every pressure sensor that you have and do your correlation check under key on engine off. Another tip I'd like to give you, if you have the luxury that vehicle that you're doing your pressure sensor correlation check has set overnight, this is an opportunity to do a temperature correlation relation check. You may have ambient air temperature, coolant temperature, cylinder head temperature. This is a good time to go in and make sure all of those are within a few degrees of each other. Now your correlation on pressure should be within 2 kilopascals or 1 psi of each other. Your temperature, probably a couple degrees Fahrenheit, depending on where these various temperature sensors are mounted on the engine compartment. We're going to go into some checkpoint questions here. The first question, the following pressure sensors are checked for correlation during key on engine off. A, baro sensor. B, manifold absolute pressure sensor. C, turbocharger inlet pressure sensor. Or D, all of the above. Baro, manifold absolute pressure, turbo inlet pressure should all be checked during key on engine off. And if you have the additional wastegate pressure sensors, those should also be checked. We're going to move on to the next question. True or false? Up to 5 pressure sensors can be checked for correlation key on engine off. It is true. If we have a twin turbo F-150, we'd have 2 wastegate pressure sensors, turbo inlet pressure, manifold pressure, and a baro sensor inside the computer for a total of 5 different pressure sensors that should be checked key on, engine off.